Okay, sweet. All right, happy Thursday. Thank you guys for putting up with kind of a weird registration day yesterday with having to wait around. Some of you had to wait around like the whole time for me to get to you. So thank you for that. If I didn't make it to you for whatever reason, or you weren't there and we still have some question marks, you'll have to get registered. And so I will see what choice you make. If I agree with that, then we'll be good. But if I think that there maybe is a better choice for you, then you and I can have a conversation. Once registration closes and they send us all that info. So I think, and don't take this set in stone, but I think it's the 27th is the day that registration closes. So you have some time to get that done. I think it's all through Infinite Campus. So just being careful signing up for whatever you and your teachers have agreed upon, and speaking with your counselors to make sure that it all looks good. Counselors have open office hours tomorrow. So if you have a question, you can drop in at certain times. I'm sure that schedule is up online on phsmustangs.com. You can check that out. Or I can forward stuff to you. Just reach out and I can send you whatever you need. I'm happy to help kind of make sure that this registration goes smoothly, because this is a weird way to do it. We've always had those, big pieces of paper, the big colored pieces of paper, and you had to walk around and get stuff signed, and kind of took away any of those question marks. Now, it's all virtual. So do the best you can. Let me know if you have any questions. Cool. So what I wanted to do, since we didn't really have a chance to do any mathy kind of stuff yesterday, is I wanted to take some time and talk through more of the same. I was looking through 2.5a and 2.5b work that you guys put up. And some of us are doing okay. Some of us have not gotten them in yet. And some of us that have gotten it done are off a little bit. Sometimes the numbers we're plugging in are wrong, or we're not quite finishing the problem, or we're not starting in the right way, and that kind of throws off our answer at the end. So I wanted to make sure that I took today and I worked with you guys. I want to do one more of these regular ones where A is 1 together. Then I'll give you one to try on your own. I'll still do the work. I'll put it up. I'll just give you a couple minutes to try it on your own. And then we will slide up one level, and I will mess around with the A value, changing it. It's not just going to be 1 anymore. I can make it 2 or 3 or 4 or whatever it is, okay? And so on today's announcement, there is a spot that says, click here to submit your work for today. That'll take you to the assignment, which is classwork 2.5C. Because this is the 3rd time that we're doing it. Okay, and usually that's how many times it takes for things to start sinking in if you've been keeping up. That's why I just want to do one with you and then let you try one. Okay. The other thing that you'll notice is that your work for tomorrow is actually already posted. So that as we work through stuff today, if you're getting it, if this stuff just clicks for you, you don't have to wait for me. You can get all 4 of our problems done today that we're going to do, and you can get tomorrow's stuff done, all 3 of those problems, whenever you want, okay? The thing you'll still have to wait for tomorrow is the attendance form that I will link there by tomorrow morning so that you can take your attendance before 3 o'clock. But your actual work, the practice, which will be 2.5D, and this is going to be the last one we do. Tomorrow will be your last bit of work on this kind of topic. Finding x-intercepts by using vertex form. Tomorrow will be the last day of that, okay? And then we'll get on to our last section. I think it's our last section with this stuff on Monday, okay? So that's that. So if you don't get this stuff yet, speak up, ask questions as I'm working through this one here first, okay? Or when you get to the one on your own, stop, ask questions. I'm happy to talk through it. We'll do 3 and 4 together. Okay, so you'll see there's 1 that we'll do together. Number 2 you'll do on your own, and then 3 and 4 we'll come back together to do those. And then the 3 that are up there already for tomorrow, 2.5D, you can start those whenever you want. So if you've got this down already and you do not need to hear me talk about it, then once I get started, just mute me and do it on your own and see how you do. Probably want to come back when we start doing 3 and 4 so you can see what happens when we have this A value that we have to deal with. But even if we just do the first one, we do number 3 and you get that, great, you can do 4 on your own. Okay, so I want to do as much as I can with you today while still giving you a chance to try this on your own. Because watching me do it is one thing, actually doing it yourself is something else. So you can either open up those problems ahead of time by going to Canvas, clicking on either today's announcement, and then getting you to classwork 2.5C, or you can just go right to assignments, which is what I'm doing right now, and opening up that Google Doc where I just made up these 4 problems, okay? So we've got A of X, B of X, C of X, and D of X, all right? Cool. So I will do this first one with you. I will talk through it as I go. I'll give you a chance to try number 2 on your own, and then we'll come back and do 3 and 4, and then we'll be done, okay? But stop me, ask questions. I had people actually like raising their hand, or even just unmuting themselves and saying, hey, Rosie, I have a question about why you did this, or how you did that, or what's the point, or whatever, okay? I don't want this to be a me staring at the camera kind of thing. I am sick of it. We are stuck in remote for at least the next couple of weeks though, right? Earliest date of return now looks like February 8th. That is our earliest possible date of return, okay? And the board will revisit that on the 2nd when they go through that next meeting. No worries, Liam, you're good. We are recording, so you can always go back and watch. All right, let's do it. Without further ado, number 1, A of X. What do we got? X squared plus 8x, I think plus 5. Yeah, cool, perfect. All right. Now, if this thing was factorable, I would just factor it. 2 numbers that add to 8 and multiply to 5. Why would I try factoring? Because the whole point is trying to set this thing equal to 0 and solve for those x-intercepts. And factoring is a great way to do that, right? But since A is 1, B is 8, and C is 5, I'm trying to add to 8 and multiply to 5. Well, I can only multiply to 5 by doing 1 and 5. That's it. And those add up to 6. So I can't do it, and that's okay. Doesn't mean I don't have x-intercepts necessarily. It just means I need this process over here to solve for it, all right? And the beginning of that process starts by finding the vertex. Because if I can go to an equation that only has a single x in it rather than 2 of them, I give myself a chance to solve this. And so I'll solve for that x part of the vertex first, which is called h. By doing what we already know is a perfect way to find that negative b over 2a, okay? And remember, negative just means switch the sign. So if it starts positive, we'll make it negative, which is what we've got, right? If it was negative, I would just switch it back to being positive. But b is 8, so now on top goes the negative 8, right? And on bottom goes 2 times whatever a is. And for number 1 and number 2, a is still going to be just 1, okay? So negative 8 over whatever 2 times 1 is. Cool, that's 2. And so h is negative 4. And that's a huge number for me. I'm going to need it. Huge in its importance, obviously not huge in size, but huge in its importance for me to actually solve this thing. And this is where it's first most important. I've got to find the number that goes with it, right? I got to find k, which is the y value of the vertex, right? We just pick some letters to kind of represent those unknown constants. And the easiest way to do that is to go back to your original function and drop in that number that we just found in for x, right? Finding that negative 4 tells me the x value. And if I want to know the y value, I just got to plug it back in. So that negative 4 is going to go right there. That negative 4 is going to go right there. And I'll let the calculator do the rest. Okay, just be careful with the parentheses. Some people I saw left off the parentheses on the homework that they submitted, either for 2.5a or 2.5b or both, and it really threw off their numbers because the calculator reads it incorrectly sometimes. So drop this all in one shot, you should get negative 11. Okay, you don't have to do it step by step. Now, sure, 16 minus 32 plus 5. Okay, cool, still going to be negative 11. Now I want to use it, right? And I want to use it right here. Ax minus h squared plus k. And I don't know that you need to write that step in red, but if you want to, you certainly can. I think it's nice because now I just know exactly where my numbers are supposed to go. Now, yeah, I'm going to put a 1 right here for a just for right now, but I'm going to get rid of it because I don't need it. But it is there, and I'm just kind of doing that as a reminder so that when we get to 3 and 4, when a is 2 or 3 or 4 or negative 5 or whatever it's going to be, we're actually going to put a number in that spot. All right, x minus whatever h is, okay? Well, it's x minus -4, right? So you got these two negatives next to each other, which when we put them together, make a positive. So it's really x plus 4 squared. Okay, always change that sign because horizontal transformations are backwards. Cool. And then plus k plus a -11. All right, minus 11, probably the best way to write that down. And that's really where my work starts. Again, I'm going to get rid of this 1 right here. It's there. I just don't need it because multiplying by 1 doesn't change anything. So that when I solve this, I just have to worry about these two numbers. Okay. And of course, I don't have to deal with that exponent as well. But the first place to always start when we're solving is at the bottom of order of operations and to work backwards, right? Undo whatever's happening on the same side of x, right? So I've got this whole thing over here, and I just want to start moving stuff over. Now, that process of kind of starting at the bottom, undoing addition or subtraction, then undoing multiplication division, then undoing exponents, all that, that's my way to do it. You could do this any way you want, but it gets way more complicated and you can easily make mistakes. This way avoids a lot of those mistakes by taking care of, like in this case, taking care of subtraction by doing addition, right? By doing the opposite. So we got a -11, so I'll add 11 to both sides. Whole point in that is to make that -11 go away. Okay, right side, just 11, right? And then I just kind of slide down. Oh, let me stick with the color scheme here. 11 on the right, and then x plus 4, still in parentheses, with the squared on the outside. I just slide it a little closer to the equal sign to make the left side look even simpler, which it is. That's kind of the whole point. Left side gets simpler, right side gets a little bit more complicated with each step. Again, I can't subtract the 4 yet. It's trapped inside, so I got to take care of that exponent of 2 that's squared by doing the opposite, which of course is to take the square root of both sides. And remember, anytime we take a square root, we got to drop that plus or minus in front. Now, why am I not putting the plus or minus over here? Well, because the square and the square root are about to cancel each other out. So I don't need that on that side because I'll just end up with whatever is on the inside, which is x plus 4. And now, just in case the square root of 11 is nice, I look for it, right? I jump into my calculator, I type it in. If I get a nice number, I'm using it. If I get a nice decimal, I'm using that. If I get a nasty decimal, I'm not. And that's what I get. I type in the square root of 11 in my calculator, and I get 3 point blah, 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 all over the place, no pattern, no nothing. Can't use it, so the best way to write it is just the square root of 11. Okay. Not quite done because I just want to get to x equals since I'm finding the x-intercept. So I might as well get to x equals. And so I will subtract 4 on both sides there. And now, good, yeah, x is done. I got x equals. So whatever's on the right-hand side, I know is going to be my answer. The better way to write this kind of weird left-hand side, since the 11's underneath and the 4 is not, I certainly can't put them together, is to put the nice stuff up front, the -4 that's not under the square root, and then put the plus or minus the square root of 11 after that, okay? If you switch that and you put x equals plus or minus square root of 11 minus 4, that's cool too, that's fine. This is just a better way to write it, and this is the way you would see it written if you ever like looked up how to do this, or answers that are written for you. Like if this was a multiple choice question, that's going to be the way the answer is going to be written, not the other way. So you just want to be careful. Bam, done. There it is. Okay, number 2 is for you. Try that one on your own first. Okay, I'm actually going to go over to that board over there, and I'm going to start doing it, but I want to leave this up for those of you that still need to copy it down or want to use this as a guide, since it's really a very similar problem. I just have slightly different numbers, right? B and C are just different, but A is still 1. Okay, so the process continues the exact same way. Okay, any questions about this? This is the 3rd day doing it, so this is the day where stuff hopefully starts to sink in a little bit more. I know we've like done it like over a period of a whole week, so I know that that's a little bit trickier. But fingers crossed, things are starting to settle in for you a little bit, and we go from there. Cool. So I'm gonna leave that up. I'm gonna start over there on number 2, and I will move the camera in just a couple minutes. I'll get it done, and then I'm gonna move the camera so you can check it out. please don't wait for me to move it for you to get started, because you will not have enough time to get it done. Okay, I want you to start this stuff on your own, nearing the end of this chapter. Yeah, what's up?
On the second one, is that is the end? Is it +6?
Where are we at?
On number 2, like the beginning of it.
X squared plus 6x plus 2.
All right.
I just I know that sometimes the equations are a little small. You can just zoom in, or you can make them bigger. Maybe I'll just do that. Let me blow up the size of the font there. Let's go like this. Boom, 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 boom. There you go. Yeah, x squared plus 6x plus 2. All right, we are on the move. I did it. But take your time. I'll give you a few minutes for sure. There you go.
Hey, Mr. Rosie.
Yeah.
So on number 3, 2x squared, would a be 2?
Exactly. Yeah.
Okay.
Yeah, and we'll do that one together in a couple minutes if you want to check it out once we get there. But go ahead and try it on your own if you want. Absolutely.
All right. Thank you.
Like 1 more minute or so, and then we will get going. But again, ask questions of anything that's up there right now if you're stuck.
And then, Mr. Rosie, so I'm trying to find K right now. So, for 2 parentheses and 2, so obviously 2 times 2 and then squared. I do 2 times 2 first and then square it, correct?
No, you're actually going to square that inside 2 first, because order of operations is to do exponents before multiplication.
So I do 2 squared 4 and then 2 times 4, which is 8.
Exactly.
Okay. All right.
Yep.
Cool. Thank you.
Yep. All right, last few moments. And if you're good, good. Take a little breather for a second. I'm right here. Getting the recording up from center. All right, cool. All right, so hopefully that went okay. Hopefully you can follow along if you get stuck, and kind of pick it up from there. The process is pretty straightforward once you get the hang of it, but it's not short. All right, you got these like 2 things you got to do over here, and then you're gonna actually do the work, right? And that's Algebra 2 for you. If that's not Algebra 2, I don't know what is, right? It's just fewer problems that just take a little bit longer, take a little bit more thinking, a little bit more understanding. But you will have your notes for the time when we eventually take this thing for real. When we take a test on this stuff, it's probably going to have to happen remote. I was hoping we would be back hybrid by the time we got this chapter wrapped up, but I don't think so. I don't think that's going to happen. And so we'll have to do 3 things, basically. 2.4 stuff with factoring, 2.5 stuff with what we're seeing right now, and then 2.6 when we get there next week. So in terms of anticipating when that test might happen, my guess, if I had to really pick a day, would either be like way at the end of next week, like Thursday at the earliest, which is possible, depending on how Monday and Tuesday go, or like Monday, the Monday we get back, that following Monday. Not back in person, but back from the weekend. Okay, so kind of keeping that in the back of your mind for getting ready to deal with stuff like this. Okay. All right, let's see what happens when A is different. Okay, looking at number 3. Not much is going to change here, except we're just not going to put 1 in for A. And we just have to deal with that as we go. So we've got this 2x squared. So there's A, right? A is 2 minus 8x plus 5. All right, so A is 2, B is -8, and C is 10. Okay. Cool. So we get to there. And, oh no, sorry, C is 5. Why did I say 10? Sorry, C is 5. I have A times C on the brain. Cool. And so I come over here and I say, all right. And maybe, I stop for a second. I say, well, I wonder if this thing is factorable. You don't have to write this down, but this is kind of what my brain would think first. 2 numbers that add to B and multiply to whatever A times C is, right? And so here's what I would be trying to do. Add to -8 and multiply to whatever 2 times 5 is, which is 10. And that's why I've been leaning on A times C this whole time, because now, and we'll get there probably sometime next week, trying to factor ones where A is bigger than 1. 2 numbers that add to -8 and multiply to 10. Not 5, but 10. But that doesn't work, right? The only way to multiply to 10 is 1 times 10 and 2 times 5. Or make them all negatives, right? Because as long as they're the same sign, we're there. And none of those are going to add up to -8. So this does not work. These are not factorable. And that's okay. I can still find my answers. I just have to go this route, right? H equals negative b over 2a. Okay. Problem that we just want to make sure we keep in mind is that if B on top there is already negative, we're supposed to switch the sign and make it positive again, right? So what goes on top, negative b, right? Negative 8. All right, so that's 8 positive 8. Okay, and on the bottom goes 2 times whatever a is. Well, a is 2. Right? So let's put the numbers together on the bottom. 2 times 2 is 4. And so even if, a is something different than 1, doesn't mean we're not going to get nice answers potentially. I could still get something nice out of that. It's cool. H is 2. Perfect. I like that. Let's see what happens when we get k. K is, 2 times whatever x is squared minus 8 times whatever x is plus 5. And in right there goes that 2. And just like Liam was saying just a few minutes ago, if we wanted to do this step by step, we follow order of operations going down. We're not solving anything, I'm just simplifying. So I have to do exponents first, which would be this 2 squared, and I would 4. And that's the only thing that I could do in that step. We solve backwards, but order of operation, like just plain old deal with numbers, we go straight down. Again, you can just plug it all in one shot, but in case you wanted to see how this played out, 8 minus 16 plus 5, and negative 8 plus 5, negative 3. Okay, now go ahead, jump straight down to there by using the calculator. I'm good with that. I'm okay. All right, might as well. Save yourself some time. There's enough difficulty in the algebra itself. We don't have to stress the arithmetic for 5 minutes just to figure out how to do that. Right? But that's how we would do it. We have to do exponents first, and the only thing being squared is the x. That's why it goes in parentheses as a reminder that that has to happen first. Okay. Cool. So there we go. There's h. There's k. Here's my setup, right? A x minus h squared plus k equals 0. And now a matters because a is 2. So that's 2 right there. X minus whatever h is just also happens to be 2. That's okay. Numbers can be shared. Squared. And then plus k plus a negative 3. So let's call that minus 3. Okay. So h and k actually worked out really nicely, which is nice. But sometimes we're going to get fractions. Like what if this was 8 over 3 instead of 8 over 4? Okay, well then 8 over 3 is the answer for h. That's what h is. Because you plug in 8 over 3 in a calculator, that's 2.666666666 forever. And I can't use that, right? If I've got a decimal that has a pattern but goes on forever, I can't use it. I need that fraction that goes with it. Okay, or maybe it's like 8 over 5. Okay, that's 1.6. Perfect. Decimal. Cool. I'll use it. I like that. Or I'll call it 8 over 5. Some people like the decimals, though, so we'll stick with that. All right, cool. Now we're ready. We did it. Took a little extra work because we had the 2 there, but not that much. Wasn't too bad. Now we just have to keep this 2 in mind as we're solving. And remember, this is kind of where my work begins. All right? This is where the algebra really starts. Here's where I start solving. And I start with any addition or subtraction that's by itself. So that little minus 3 at the end seems like a good place to start by adding it. So I've got the 3 on the right, and let's kind of bring everything down to 2, the x minus 2, and the square. And so that's basically how we've started every problem, right? Take care of that adding or subtracting at the end. Now, for the first time, I've got an a that's sitting out in front right here, okay? That a is being multiplied through everything else, right? Because if you have parentheses and you just got a number out in front, it's connected by multiplication. And so just like we did the opposite of subtraction, we did addition to get the 3 out of our way, we need to do the opposite to this left side to get the 2 out of our way. And since the 2 is connected by multiplication, we need to divide. So I just make like one big fraction bar going across on the left side, okay? And I divide by whatever a is. If it's 2, I divide by 2. If it's 3, I divide by 3. If it's -5, I divide by -5. Whatever that number happens to be, that's what I'm going to divide by. Okay, and I'll do the same thing on the right. Okay, divide that 3 by 2. So that's kind of my new step. It's the only thing different about my algebraic work right here so far is having to actually divide for the first time. Before, it was just ×1. I didn't have to divide, right? It was just, okay, cool. It was just 1. But now that I divided by the 2, now I can cross them out. And I don't change anything about the inside because none of that inside is affected because it's trapped inside the parentheses, right? Only the things on the outside can be affected. Cool. So now I can bring all that stuff down on the left. X minus 2 squared equals, well, 3 over 2. Well, 2 doesn't go evenly into 3. So I know I'm not going to get a perfect, nice whole number like I did here when I had a fraction to start, but things worked out nicely. But 3 over 2 is perfect, right? You can, that's the simplest version of that fraction. And so if you want to write the fraction 3 over 2, love it. Write it just like that, right? Just like a fraction. Or you can check to see if that fraction gives you a nice decimal in case you prefer those. And you have the freedom to do one or the other if our decimal is nice. And so maybe you jump in your calculator and you say, okay, 3 divided by 2, enter, and you get 1.5. I'll take that. That works for me. I'm good either way, whatever you prefer. If you like the fraction, just make sure it's simplest, as simple as can be. Or if the decimal has an end, feel free to use it. Okay, I like the 1.5. I'll stick with that right now. But I'll show you what it looks like with 3 over 2 at the end. I'll show you what the answer would look like. But there it is. Like, that's the only thing different was the dividing by 2. Now we just kind of pick up right where we would have left off if we didn't have that 2. We get ourselves to the step where we're ready to undo the square by taking the square root. Right? So I'll take the square root to the left, square root to the right. And I'm going to stop and check. Like, I'm coming down to my calculator because honestly, I don't know what the square root of 1.5 is. 1.5 square root of that. Square root. 1.224744871. No. Perfect. Just like that. I don't care if there's a decimal underneath. It's way better than writing a decimal that doesn't end. This one ends. So I know I can use that. All right, square and square root cancel each other out, so I just have the x minus 2 plus or minus square root of 1.5. Add that 2 over for our final step. X equals, I'm going to put the nice one up front, the 2. It's positive. I don't need a plus sign right after the equal sign. X equals 2 plus or minus 1.5. Perfect. Just like that. Now, if you really wanted to, and you like the fraction version better, you just have to make your square root a little bit taller to be able to fit the whole fraction underneath. That's the thing that some people don't like about fractions is they take up more vertical space than decimals. And now I got to put a square root over that, so it takes up even more space. You can see how much further above and below everything else that square root of 3/2 does take up. That space just, it's a little bit bigger. And if you're like writing on lined paper, maybe you don't like that it's spilling onto like the line before or the line after. So if that bothers you, use the decimal. As long as it's got an end, you can do that. Okay, so this is the only thing right here. That's the only step that was kind of funky, right? And of course, this is the first time we've really dealt with decimals, but there they are. No big deal. It's just a decimal. Okay, so there you go. That's an Algebra 2 problem right there, if I ever saw one. That's a good one. All right, so I'll leave that up for a second while I erase number 2 over here. We'll do number 4 together. But if you want to just get a jump on it, go ahead. You don't have to wait for me. It's the same kind of thing. It's the same kind of process. Okay, questions on that one before I move the camera to the other side? I'm out of water. All good? Sweet. All right, let's do it. Because then we can get you out of here a little bit early, which is always good. Okay, and again, do this on your own if you want, okay? Or if you've already done it, start knocking out classwork 2.5 D, right? Which will be the last time we really do this stuff. Go for it. Try it on your own. You don't have to wait for me. Okay. The work from today, 1, 2, 3, and 4, got to get uploaded today. Okay. Work for tomorrow can get uploaded anytime between right now, and midnight tomorrow. It's only the attendance form that I need by 3 o'clock. All right, cool. Number 4, let's do it. Same process, new numbers. D of x. What's a this time? 4? Yeah, 4x squared. Minus 12x plus 1. All right, cool. So there's my function. A this time is 4. B is negative 12. Don't forget that negative out front, something important we want to make sure we keep track of, because that's the B that we know we have to switch the sign anyway. And I would love to try to factor that, right? You don't have to write this down, but here's like what my thought process would be. 2 numbers that add to B, so add to negative 12, and multiply to whatever A times C is. That's multiplying to 4. 1 and 4, or 2 and 2. Even if I make those negative, which they would both have to be to add to a negative, I'm still never going to make it to negative 12. So this is not factor. Which means when I take the square root of numbers like 2 or 11 or 1.5 like we have so far, I'm going to end up getting that not so nice decimal. But let's figure out what we're going to be taking the square root of by finding h and k. Cool. So h equals negative b over 2a. All right. B is negative again. So switch the sign, make it positive. 12 over 2 times whatever a is. This case, a is 4. So I have to take care of that denominator first. That's kind of like the grouping part of GermDAS. I have grouped multiple things together on the bottom of a fraction, and I have to do that stuff first. I have to do 2 times 4, get 8. Then I can actually divide, okay? And 8 does not go evenly into 12. And so you can either simplify that fraction by finding a number that goes evenly into both and dividing by that everywhere. So 8 doesn't go into 12, but 4 goes into both of them. So if you divided both of them by 4, you'd get 3 over 2. Great, you could use that. Or, hey, I recognize that number. That's 1.5. And for now, I'll just stick with the 1.5, just to make it easier. Okay, so there's h. There's the x value of the vertex. Right. So sometimes, even when a is nice, like or when a is different than 1, we can still get a nice h and k value. That can still work out sometimes, but sometimes not. Right? Sometimes the numbers don't go perfectly into each other. Whatever it is, let's just use it. Okay. Trust your work. If you're doing it right, you'll be in good shape. All right. 4 out front, something squared, minus 12 times something, plus 1. In goes 1.5. Okay, and that is definitely not something I am going to try to do by hand. That's definitely a calculated thing, because I have to square a decimal, then multiply by 4. Then I've got to multiply a decimal by a number bigger than 10, which is kind of tricky sometimes, and then add a number to it. No way. I jump right into the calculator. I see what happens. I press all the numbers all at once. Somehow, magically, I get a whole number back. It's because we're multiplying decimals by numbers that work out really nicely. I think, let me just check to be sure, but I think it's negative 8. Yeah. 4 times 1.5 squared minus 12 times 1.5 plus 1. Yeah, negative 8. Perfect. Okay. And so even though my h wasn't really, really nice, it's not too bad, but not really nice, I can still potentially get a nice k value back. Or maybe not, right? Let the calculator kind of guide us, right? So I forgot to set it equal to 0. Let's do that part first. Set the function equal to 0. Now I want this version instead. I want that nice vertex form where a goes here, so that's 4x minus 1.5, okay, squared plus a negative 8, so let's just call that minus 8 equals 0. All right, so we've got a decimal we'll have to deal with in this problem. Let's see how that shakes out. Okay, adding and subtracting first, then multiplication and division. then exponents by doing the opposite. So I got this -8 out here. Let's do a little plus. A little plus. Cool. So those are gone. Nice. Right side is 8. Bring down the rest. 4x minus 1.5 squared. Okay, addition, subtraction done. Moving up one level, order of operations says take care of multiplication and division next. So I'm looking for anything on the same side as x, since that's what I'm solving for, that's being multiplied through everything, like a big number that does it all, right? And that's what this 4 is doing. That 4 is being multiplied through everything else on that whole side. So I know that if I divide the whole side by that 4, just one big fraction bar going all the way across, I know that they will cancel out. But whatever I do on the left, I better make sure I do on the right so I stay nice and balanced. And I'll bring down that left side that is still untouched, the x minus 1.5 squared. Again, you want to call that 3 over 2. Great. Love it. I love fractions. They're actually a lot easier to deal with in upper level stuff than decimals. And we got really lucky. 8 divided by 4 is 2. Perfect. Great. I didn't even plan that. When I made these problems up, I just made them up. But that worked out really, really nicely. Okay, 8 over 4 is 2. That could have been some other decimal or some fraction. Whatever it is, we just write it down. Cool. Square root both sides. Square root to the left. Plus or minus square root to the right. Square and the square root cancel each other out. X minus 1.5. I jump in my calculator. That seems to be a trend with me. Checking things out in the middle of the problem. Like way back in the day, we'd have a problem and we just plug it in, we were done, right? Now we're plugging numbers into the calculator kind of in the middle of the problem to see if there's something easier that we can do. Like 12 over 8, not the best version of that. 1.5, definitely better, okay? Square root of 2 is not pretty, so we'll just leave it, square root of 2. Finally, do the opposite with that. 1.5 x equals, I'm putting the nice stuff up front, the square root at the end. Voila. There it is. There are our problems for today. And we got done early. Nice. 7 minutes early, 8 minutes early. Good. Okay, so it shakes it up a little bit because we have to keep track of that A here, right? Here, as we're working through it, and of course here, as we divide that thing away. But the actual steps, steps 1, 2, and 3, that's a J, right? So just kind of growing in our skills, that's all it is. There you go. Okay, I'm done. I'm good. Make sure that you get your stuff submitted to Canvas for today, those 4 problems that we just did. Anytime you want, get a jump on 2.5D. That'll be due tomorrow. And then just check tomorrow for the link to the remote attendance form so that you can take your attendance on the day. Questions on anything? Anything that I can answer for you guys?
Hey, Rosie.
Yeah.
Did you get my email?
I got a message from you today. Yeah. Did you send a second one or?
Sorry, say that again.
I got the first one.
All right. Thank you.
Yeah.
Have a good.
Thanks, man.
Thank you.
Thanks, guys. Have a good day. Have a good day.
Thank you. Have a good day.
But I will hear. Otherwise, I'll see you guys Monday. Thanks. See ya. Stick around for questions. Otherwise,
I just submitted the assignment.